Model 2, signal degradation in optical fiber. So we know very well about this block diagram. In the first part is analog signal. That analog signal is converted into an electric form, right? That electric signal is again converted into a light source, and that light source is transmitted through the fiber optic cable, and at the receiver side you will have a photo detector that will convert light source into an electrical signal. Again, that electric signal is converted into an suitable form, an analog output. This is the procedure for transmitting the signal through fiber cable, optical fiber cable, right? And now uh, during transmission there may be a loss of signal, right? There will be a loss of signal due to several parameters, right? We will see one by one. Losses in an optical fiber. There are various types of losses. One is attenuation loss, absorption, scattering, bending, dispersions, and coupling losses. These are the various losses involved in optical fiber cable, right, during the transmission of signal from source to destination. First one is, we can see attenuation. Attenuation in an optical fiber is caused by three parameters. One is absorption, scattering, and bending loss. Absorption, attenuation means there is a loss of power, right, during the transmission. There is a light, optical light transmitted from source to destination. During the traveling path, right, there may be a loss in the optical signal, right? That is termed as an attenuation, right? So attenuation is the loss of optical power, right, as light travels along the fiber cable, right, from source to destination, right? Here uh, signal attenuation. What is meant by a signal attenuation, right? Again, it's a ratio of uh, optical input power to the optical output power, that is input power by output power. Signal attenuation means it is defined as the optical power input to the optical power output. Optical power input is the power that is optical signal injected in the transmission side, right? Optical output power is the power received at the fiber end or at the detector end, right? And we can define these in terms of equation. So attenuation equal to logarithmic of kilometer, that is 10 by L, logarithmic base 10 of pi by p naught, that is optical input power by logarithmic base 10 of uh, optical input power to the optical output power. Attenuation is the 10 by L, where L is the uh, length of the fiber cable in terms of kilometer. The unit is decibel by kilometer, right? Attenuation unit is decibel by kilometer, you can say. So signal attenuation, again previously I told you, it is an ratio of power input by optical power output, right? The formula is 10 by L, that is L is the length expressed in kilometer, so dB by kilometer, it is the unit is dB by kilometer, decibels by kilometer, where L is the length expressed in kilometer. So attenuation is caused by absorption, scattering, and bending losses. We'll discuss one by one. What is absorption? What is scattering? What is a bending loss? right? And each mechanism, that is absorption, scattering, and bending loss, is influenced by the fiber optic material property and the structure, right? Two important terms: fiber optic material and properties fiber structure. These two is the main connection for the losses in the fiber optic cable. First one is absorption. Absorption is the uh, is a major cause for signal loss in an optical fiber. This is defined as the portion of attenuation resulting from the conversion of optical power into an another form such as is. Okay, during the traveling of light source from source to destination, there will be a loss of signal, right, in the form of heat energy, right? So in the form of heat energy, uh, this is the major losses, major causes for a signal loss. Absorption of energy, uh, such as in terms of heat, and this absorption is explained by three factors. One is imperfection in the atomic structures of the fiber material, and next one is intrinsic fiber material property and extrinsic fiber optic material properties, that is presence of impurities, right, and pure materials. So these two are the three factors affecting the causes for the signal losses, right? First point is imperfection in the atomic structure of the fiber material. Imperfection means presence of any missing molecules or any oxygen defects, right? That may cause, right, losses of signal, right, losses of signal. And next one is uh, intrinsic and extrinsic material properties, right? uh, if a fiber optical fiber was absolutely pure, right, that is with no imperfections or impurities, then all the absorption would be interesting, right? These sets the minimum level of absorption, right? If it is a pure material, we have some minimum level of absorption, whereas in extrinsic absorption is caused by the impurities introduced in the fiber material, right? Suppose any trace metal impurities such as iron, nickel, chromiums are introduced into the fiber during fabrication, right? These may create losses of energy or electronic transition of these metal ions from one energy to another, right? So there will be a loss of signals in terms of heat, right? So these are the two major factors for signal losses, right?